Tesla full self-driving and Waymo are frequently discussed as if they were identical technologies. However, evaluating their engineering and operational limits reveals they are pursuing two different goals. Welcome to Wandt Quick Take, an AI-narrated educational video series exploring important topics in artificial intelligence, cybersecurity, and technology. Each episode draws from source materials connected to Professor Adam Scott Wandt of John Jay College of Criminal Justice, including lectures, notes, research, recordings, and earlier works. The series is designed for public education and provides a cinematic overview of those materials. This episode was assembled using artificial intelligence. The final narration and presentation may not always fully reflect Professor Wandt's precise views, wording, or intent. Online debate treats this as a singular race to achieve self-driving, yet the hardware and software strategies behind these companies are moving in opposite directions. To understand the split, we use the SAE levels of driving automation, which scale from 0 to 5 based on the system's independence. Tesla full self-driving, supervised, is a level 2 driver assistance system, meaning a human must remain fully engaged. Waymo operates as a level 4 service, where the vehicle handles the entire driving task within a specific area without human intervention. Collapsing the distinction between a driver-assisted vehicle and a driverless service creates significant confusion for regulators, insurers, and the public. Tesla's approach is built for generalized deployment. The company designs its software to assist drivers across nearly any public road they encounter in their daily lives. This strategy relies on the Tesla Vision architecture. Unlike many competitors, Tesla has transitioned to a system that uses cameras and neural networks to interpret surroundings, intentionally removing ultrasonic sensors and radar. The advantage is massive data collection. With hundreds of thousands of customer vehicles on the road, Tesla continuously captures real-world driving scenarios to refine its software via over-the-air updates. However, this technology does not make the vehicle autonomous. Tesla's own documentation explicitly states that the system requires an attentive human driver who must be prepared to take control at any moment. Tesla provides a scalable AI assistant that can operate broadly, but only as long as a human is there to supervise its performance. Waymo focuses on a narrower, more specialized task, operating a commercial, driverless transportation service. To achieve this without a human backup, Waymo uses a redundant sensor fusion stack. Their vehicles combine cameras with LiDAR and radar to build a precise, three-dimensional understanding of their environment. This performance is tied to an operational design domain. Waymo vehicles are strictly geofenced, meaning they only operate in areas that have been extensively mapped and pre-approved for driverless deployment. Waymo trades geographic reach for full autonomy, ensuring the system can handle all driving tasks within those verified, localized boundaries. These different engineering paths create entirely different vulnerabilities and safety risks. Tesla's supervised model faces significant human factors risks. Overtrust in the system can lead to driver complacency and misuse, especially when the marketing language suggests a higher level of capability than the technology actually provides. Waymo's model faces operational complexity. Its reliance on expensive hardware and high-definition maps means expansion is slow, and the system can be sidelined by unusual weather or construction that falls outside its pre-validated parameters. Assessing safety requires looking past general claims and identifying whether the risk lies in the person supervising the machine or the environment surrounding it. These technical differences have immediate consequences when an incident occurs, and investigators must determine liability. In a crash involving a Level 2 system, the focus remains on the human driver. Because they are legally responsible for the vehicle, negligence typically hinges on whether they were paying attention to the road. In a Level 4 driverless crash, there is no driver to blame. Scrutiny shifts entirely to the vehicle's software logs, sensor accuracy, and whether the operator complied with the strict requirements of their deployment permits. Both systems generate massive amounts of telemetry and location history. This creates a new landscape for digital investigations, where crash data and sensor records become essential evidence in courtroom proceedings. The fundamental design of the vehicle dictates how law enforcement, insurance companies, and courts assign responsibility after a failure. Impressive performance in one environment does not guarantee safety in another. technical capability is only meaningful when balanced against the specific context in which a car is operating. Evaluating any autonomous claim requires answering 3 questions. Who is responsible for the driving task? Where is the system allowed to operate? And what happens when the technology reaches its limits? Defining these boundaries provides a practical foundation for testing vehicle reliability and drafting clear safety standards for automated mobility. Like, follow, and subscribe for more deep dives into emerging technology, digital evidence, and the legal questions surrounding automated systems. And remember, stay curious and want knowledge.